Right. Everyone. Looks like I'm the what's between you and dinner. So I will try to keep this brief. My name is Hauke Hund. I'm a software developer and researcher or data researcher at the GECKO Institute of Heilbronn University of Applied Sciences. I'm here together with my colleague Max Kurscheid, and I'm happy to talk to you a little bit about our journey to Operaton and why the compiler sometimes doesn't get the last word. What we do is we work in data-driven medical research as software developers, and what we are especially part of are these four research networks across Germany. And with our data sharing framework, we currently have about 50 installations, mainly across all the university hospitals in Germany, but also some other research institutes. In 2019, the German government decided to put in a little bit of money into data-driven medical research, and we're happy to be a part of it. And so the open source development of the data sharing framework started in 2019 as part of the so-called HIMATE consortium. What is the data sharing framework? It consists of two elements. One is a so-called FHIR server, or for those of you who are not part of the medical science community, the FHIR standard is a standard, a relatively modern standard in healthcare for storing data and exchanging medical data between organizations, structured medical data between organizations. And of course, Operaton and the business process engine world, I don't have to explain to you. What I want to explain here on this slide is that the FHIR server lives in a public network, so it is accessible from the internet, of course, with authentication and all that jazz. But the business process engine itself lives in the internal network of the hospital or a research organization, between, of course, or behind, of course, a big firewall. And one way how we integrate those two worlds with each other is that the business process engine talks from inside to the mailbox, if you will, that lives on the outside. Currently, our installations in our major version 1 are running on Camunda, or the latest version of Camunda 7. But with our next version, version 2, that we will release in a few days, so we'll have our own launch party in a few days, we will switch over to Operaton. One instance is of course not enough, because if I only want to talk to myself, I don't have to do this. But what we can do is we can take multiple of these instances and link them together. And our software is, or the framework is designed in a way that you can have multiple network topologies, any kind that you want. So you could be, if you talk here about the red, if you think you are the red dot here on this slide, you could be part of a more centralized network where everybody talks to a central node. So for example, every one of these organizations has to send research data to a central node for a specific project. Or you could also be, and you could also be at the same time with your instance, be part of more of a peer-to-peer network where organizations send medical data to each other. Or medical data is sent from one organization to the next, and so on. And what we can do in our application is that we configure this topology via our allow list. I won't go into details here. If you are interested, I have a URL for you to go in the end. But suffice it to say, our application by itself doesn't do anything. So what we need is, of course, a way to support any kind of use cases you want to do in research. So, and for this, we have a plugin mechanism. And this is the way how we have our users create their own processes and bring them into this application. But what we can offer them is an instance that is already running on in your organization, so that all the firewall stuff or the organization stuff is already done. And if you want to go ahead with your research project, then all you have to do basically is to develop a process plugin and put that into your local instance. And this process plugin, of course, has BPMN2 in it. That's why we are here. So the why, or what we want to do, is modeled in BPMN. Then it has Java code in it, because something needs to happen, otherwise this is not really useful. And then there are some FHIR resources, and I'm not going to go into that here, for defining the structure. So what is actually transported between organizations. And in the end, all of this is packaged up as a jar file. And then, of course, you deliver that jar file to the users, or all the members in a network that want to talk one business process with each other. And what we do is that we load this jar file with our own in its own class loader, so that we also support multiple versions of the same process running at the same time. So this is one thing that where we had to hack a little bit on the process engine, so that at that part in the engine where it decides to, for this service task, please execute that Java class, we have a switch that tells us, don't just call this Java class on the class path, but actually use this class loader to get the correct version of that class, because we might have multiple versions at the same time in the same JVM. Yeah. So here's an example, and finally an audience where I don't have to explain BPMN to. This is a process, or a simplified version of that process, that we execute to test connections between organizations. From a research perspective, this does nothing. It only checks if the network is set up correctly. And the only thing I want to explain here is that for this part here, where the process instance here in the beginning that starts everything talks to all the other nodes in the network. For all these message events, that is basically the rule within our framework. Every time you have a message event that crosses organizations, then there is a so-called FHIR task resource within this healthcare data standard that gets transported over the wire, that starts then the process on the remote instance. So this is the way how we connect the locally running business process instances with each other, and creating this distributed network, as I was saying. Our is now for the more technical stuff on how we switched from Camunda to Operaton. One last background slide here. If you are a Java developer, this is not news to you. When your application starts, a bootstrap class loader loads your JVM native code. Then comes the platform class loader that loads JDK classes. Then you have your system class loader that loads all your application classes. So basically all that stuff that's configured via class path. I'm not talking about module path, because that's a different world. But this is basically usually what you do, and you're done here. And if you want to have plugins in your system, then in the Java world, you usually use the service loader mechanism to load stuff from jar files that are not statically linked. And what we have created is also these two layers together, because we also want not just to have, as I mentioned earlier, multiple versions of these process plugins running at the same time, but also these process plugins may have different dependencies from different libraries that use multiple versions at the same time. So this is why we have these two layers of class loaders there as well. Before Camunda decided to announce the end of life for Camunda 7, what we already did was to create a second version of our process plugin API. The first version of our process plugin API that everybody currently uses in production has a direct dependency to Camunda. So Java Delegate is, I think was mentioned already today, is the typical interface that is implemented here to have these service tasks in BPMN. But of course, this is a direct dependency to Camunda, and you can't just switch that off, especially if you don't want to re-implement your process plugins. But what we already did, as I mentioned before, Camunda, we're announcing the end of life, was that we created a version 2 for our process plugins with an abstraction layer that didn't have any dependencies to Camunda anymore. And of course, now you could say, well, thank you for your talk, we're done, because if we only had our users switch to version 2, then we didn't have a problem, because re-implementing this abstraction layer is, of course, very easy, because it's basically just replacing some package names. But it wasn't this easy. So we had two options on our road to Operaton. We could use easy mode, just as I mentioned, switch all our users to version 2 of the API, then have one big integration party where all the organizations switch from our current major release to the next major release, and everybody's happy. Of course, with the risk that nothing works anymore then. And of course, also with the problem that the process plugin developers needed to develop their new process plugins and switch to the new API at the same time that we want to roll out our application. So less work for DSF core developers, for me, but more work for our users and more work for our process plugin developers. And so this is something we didn't choose. We should have, but we didn't. And or maybe we should have, at least for my sake. And so we used hard mode. And hard mode, the idea was find a way to support version 1 plugins with their Camunda dependency on an Operaton workflow engine. First of course, we had no idea how to do this, but then it became I won't say easy, but it became clear after I talked to ChatGPT for a while. No, not really, but it did help a little bit. At least it helped in choosing the correct library to do this. Because as you know, Java code doesn't get compiled down to native system code, native CPU code. It gets compiled down to bytecode. And bytecode is something you can manipulate. It doesn't need to stay the way the compiler told you it is. As I mentioned, version 2 of our API, easy, just switch the underlying layer from Operaton to Camunda. That was done in an hour. And then version 1, the idea was manipulate the bytecode while it is loaded to make sure that it runs on Operaton and not on Camunda. And what you can do here is use bytecode manipulation libraries, and there are multiple ones out there. In the beginning, ChatGPT told me to use another library, but that turned out to be a dud because it didn't give me enough control over the process. ASM is the most low-level library to do this, I think, in the Java world. And yeah, what you basically do is tell the ASM library, please load this class, or here's the class. Please replace org Camunda BPMN with org Operaton BPMN. And then, of course, you need to be a little bit clever about it because there are multiple places where classes are referenced in the bytecode. This can be constants, there can be fields, you can have methods, their return types or their parameter names, and you can of course have, if you are on a more modern Java version, these fancy invoke dynamic calls for lambdas and method references and so on. And if you do the right stuff, and you can look this up, it's of course open source. It's 2 pages on my monitor code. It's not really that much actually. And you switch all the packages, then the process plugins work. Of course, since not everyone uses process plugins like we do, this is not a general way of doing this, because what we don't do is switch class names, which have Camunda in them and now have Operaton in them, because we don't need to. And we also don't switch constants which are something Camunda and are now something Operaton. We were a little bit, but I'm pretty sure that it shouldn't be that hard to adapt this code and also switch class names and also switch constants from the now Operaton library. Yeah. So in the end, hard mode wasn't that hard actually. But to summarize this, we are creating have built a distributed business process engine, and our next version 2, will have Operaton in it, and then give us a few months. But after that, I'm pretty sure that we will have rolled out that version to all the university hospitals in Germany and some other organizations. And yeah, API version 1 was runtime bytecode manipulation, and version 2 was just an abstraction layer. So with that, the class loader got the last word. Okay, with that, I'm at the end. So let me thank you for listening, and especially let me thank all the Operaton developers for getting us here. That was quite easy on our end. So congrats. And if you have any questions, feel free to ask me. But if I can direct you to dsf.dev, there's everything you may ask. Also the link to our GitHub. I didn't want to put that on the slide, but the project is open source, so feel free to have a look at it, and feel free to contribute if you have time left after Operaton. But for any other questions, especially if you want to talk to my boss, send us an email. Thank you.